So today I'm going to explain to you the MergeSort algorithm, and then we are going to do the Python implementation. So the name should actually have been split and merge, because there are two steps. Step one should be the split, and step two is actually the merge. So this step one is split, and step two is actually the merge. So what happens in step one? Let's take this example right here. So you're going to split this array into two parts. You're not going to split it arbitrarily. You're going to choose half of the array. So it's going to give you two arrays. A1 is equal to 4 and 0. And A2 is going to be, so you mean this is A1 and this is A2 is going to be 9 and 2. And in the next part, we are going to go ahead to split these two. So we are going to have, here we now have, we're going to have 4, and we are going to have 0. And here we are going to have 9, and we are going to have 2. Now, if we merge these two arrays, we are going to merge it by taking the smaller item, and it's going to be 0, and the second item is going to be 4. We're going to also merge these two. We are going to now have 9 and 2. So basically, we are merge sorting these two empty arrays because they are already sorted. So how do we now merge these two? You need to pay attention to what I'm going to do now. So the first thing is going to be, you want to have two indices. For instance, you have I here and you have j here, all initialized to 0 and there's 0. So I'm going to compare I0 and J0, which is 0 and 9. Sorry, so I think I made a mistake here. So this is going to be actually 2 and 9. Okay, so in this case, remember, if you just merge these two, they are not sorted. You have 0, 4, 2, 9 is not sorted. So to merge it, you have to use comparison of the indexes at corresponding locations. So at I is equal to 0 and j is equal to 0, we have 0 here, we have 2 here. So in the final array, we are going to now put 0 in there. Okay, we are going to move I pointer to this place, and we're going to compare I1 and J0, which is 4 and 2. 2 is smaller, we're going to move 2 in here, and now I is exhausted. So at this point, I has become the length of the array. We are simply going to, so we have 0, okay, so we have to do 4 and 9, and then we are going to place 4, and then we simply, this is exhausted now, we simply move 9 in here. We'll have a sorted array. I think when I write the code in Python, it's going to be much more clearer than this explanation, because it's quite intuitive. It's one of the most interesting algorithms out there if you actually learn how it works. So the first thing we want to do is to have a function called MergeSort. Sort. So this MergeSort is going to take an array, ARR, and the first thing we want to do is to check if this array is a single item. So if the length of the array is either less than or equal to 0. If it's less than or equal to 0, we simply return the array. We don't need to sort it; it's already sorted. We simply return it. Else, we are now going to split this array into two parts. So let's have ARR1. This ARR1 is going to start from the beginning of the array to the middle of the array. So it makes sense for us to calculate the middle of the array to be len ARR floor divided by 2, because we don't need any decimal place. So ARR1 is now going to be the array going from ARR going from the zeroth item to the mid, right? Like this. So, but normally I can remove the 0. If you remove the item at the point of the slice, then it's going to start from the very beginning. And ARR2 is going to be ARR going from mid all the way to the end. If I don't put anything like end or whatever, or the length of the array, it's going to know that it's going to go all the way to the end. Now we are simply going to merge the two arrays. Actually, we are going to merge sort this array and this array. So I'm going to actually just add merge sort here. So we are going to merge sort these two arrays. So instead of having another variable, let me just merge sort them in place. So I'm going to merge sort this array here and it's going to be like this, okay? So at this point, we have two arrays that are sorted. Then we are now going to merge them. So I'm going to simply return the merged array by calling the merge function and passing in the two arrays, array 1 and array 2. So this is simply what you do in the merge sort. Now the next thing I want to ask is, how does this merge work? So the merge actually takes two arrays and is going to be comparing the corresponding elements at each given index. So let's write it, and I think it's going to also be very clear. So I have to define merge. The merge function is going to take array A1 and array A2. And yeah, so at this point we want to have two indexes. As I told you, we have index ij, each of them starting from, for I is going to be iterating A1, j is going to be iterating A2. So we're going to have I, and j is going to be initialized to 0 and 0. And we are going to have another array to hold the final output of the merged array. So I call this array that's going to hold the final result to be C. Okay, so we are going to begin our iteration. We are going to be iterating while the I have not gotten to the end of A1 and j, which is iterating A2, has not gotten to the end of A2. We are going to continue iterating. So while I is still less than the length of the array it is iterating, and j is less than the length of the array is iterating, which is A2, we are going to continue iterating. So at the point of I0, J0 are the corresponding elements in the two array. We want to check which one is smaller and then move that one to the C array. So I'm going to say if AI is going to be actually A1I is less than A2J. So if this is the case, we are going to now move the lesser one, which is A1I, onto C. So I'm going to say C dot append and give it A1I. Okay, so this is what we do here. Else, we are going to now move in. Of course, after this, we are going to increment the I counter by 1. And else we are going to append, it means that the other one, which is A2J, is smaller. So we're going to append A2J onto C. So it's going to be A2J appended to C. And of course, we are going to increment our J by 1. All right, so after adding it at this point, at the end of this loop, when this loop exits, it means that one of these I have gotten to the end of the array. Either I have completed iterating its element but j remains, or j have completed iterating A2 and I remains, but we don't know. So we are going to use a check to see. So if it is actually I that completed, so if I is what got to the length of the array A1, if I completed iterating its element, then it means that I have completed its element, but there are some elements in J. We are simply add all those elements onto C, and we are going to use C.extend this time and simply add the remaining element of A2 onto C. So C.extend are going to be adding A2 and the remaining element from index J onto the end, and else is going to be, actually we don't need an else statement. So if on the other hand J have completed iterating the array A2, so it's going to be A2, then we are going to know that there are some elements left in A1. We are simply going to extend as well, C.extend, and give it A1, and it's going to be from I to the end. So this is basically how it works, and at the end of the day, I'm going to simply return C like this, okay? At the end of the day, we simply return C. So this is exactly how MergeSort works. So it's quite intuitive, take some time to get your head around it. So I'm going to just reduce the size, the spaces here, so that you can see the whole functions in one screen like this. So I have the merge sort here, and we have the merge here. And now let's test it out by calling MergeSort on A. So I'm going to say sorted array. I'm going to now call MergeSort on A. So I'm going to call MergeSort, giving it A, which is this unsorted array here. And I'm going to now print out the sorted array, and let's see if it actually works. So I'm going to click here, and it tells me recursion depth, maximum recursion depth. So there's a problem. Let's go check where the problem is coming from. If len ARR is less than or equal to 1, not 0, sorry, so it's going to be less than or equal to 1. Yeah, so I'm going to run one more time, and this time you can see it actually worked. It sorted the array and is giving us back the sorted array right here. So this is how MergeSort works. I'd like to thank you for viewing. Please take some time to get your head around it, because many other sorting algorithms actually will be clearer once you understand the MergeSort algorithm. Please remember to subscribe to my channel. Leave me a comment if you have some challenges or you have some coding challenge you would like me to crack. And like and share this video as well. I remain Kinton the Tech Pro, and I'm always there for you.